Okay, on the cloud side of things, these are the type of services that we test here. We have some REST API services, web applications, and mobile applications. Mobile applications are a little different, so I'm mostly going to be focusing on REST APIs and web applications. These are the tools and libraries that we use in the current solution. We use .NET Core to build the framework, as well as specifically the HTTP client library to do our API testing, Selenium for our web application testing, Appium for mobile application testing, and XUnit for the test runner. And one thing that I want you to notice here is all of these technologies are open source. This is a general architecture diagram of the solution, and that I want to go over a little bit. So I'll start from the top and work my way down. The test runner is a project. It's a custom test runner which invokes test cases from the test projects using XUnit. And these test projects, they will each have some number of test cases. And these test projects, they will also share some code in this test context project. And from there, each test case, it can make calls to the framework using one of two paths. It can take either the API path or the UI path. So when it makes calls to the framework, for the REST APIs, it'll go through this project in the framework and then use the HTTP client library in order to make those REST API calls to our cloud services in AWS. Or if the test cases call the UI libraries in the framework, then they'll use Selenium in order to perform actions on the deployed web applications. And then both of these projects, the API side and the UI side, they have a lot of differences, but they do share some code in this common project. And to zoom in a little more on the UI side of things, on the web application testing that we do with Selenium. So from the test side, we use the page object model with our web application Selenium test. And I didn't want to go too much into explaining what page object model is because I think there's already a lot of good resources on that. But we do use page object models, so the test cases, they will make the calls to different page objects. And then I guess the one more key part that I want to point out here is all of these page objects, they do not make calls directly to the Selenium libraries, but instead we kind of funnel all of the calls from these page objects into our Selenium wrapper class, and only our Selenium wrapper class is the one that makes calls directly to the Selenium libraries, which then performs the actions on the browser. And for running the tests, there's two suggestions that I would like any automation engineer to consider if they're not already doing. And so one would be to use a CI/CD agent, such as Jenkins, in order to run their automated test cases, as opposed to running them locally or something like that. And then also try to use Docker if possible. And the benefits gained from these two actions is anyone will be able to run the automated tests, usually with just one click from the CI/CD software such as Jenkins. And then there will also be no prerequisites like cloning the repository or installing anything or having a specific OS, nothing like that. So additionally, specific for Docker, the tests will also be more reliable because there's less problems that can occur due to changes in the host machine. And then for our CI/CD pipeline, the way we have it work is DevOps, they'll deploy a cloud service, and then automated tests will be triggered after any of those deployments, and those automated tests will include sanity tests for the deployed service and environment. And those tests, they'll run in Docker containers and on a CI/CD agent, in this case Jenkins. And after the test run, the reports will, the results will be reported to Slack. And so this kind of a pipeline, it allows for quick and constant feedback on the quality of the builds. So to wrap things up a little bit, we wanted to conclude with some additional resources for anyone who doesn't know maybe which direction to look for more information, more learning material on test automation. And I'll admit that there's a lot less information compared to like developer information, for example. But some of the resources that we like, depending on which kind of format you prefer, for videos, we like Pluralsight and Udemy. Blogs, this testing curator blog, it consolidates testing articles from all different sources. And then so for books, Clean Code is always a good book for everybody, and Practical Object-Oriented Design is another one that one of our automation engineers loves. And now we'll have questions.
You showed a testing pyramid in one of the slides. The question I have for both of you is how well your situation is aligned with that pyramid. Do you comply with how it is shown, or is it a inverted pyramid or something in between?
So the question was, how well do we comply with the testing pyramid here at Bluebeam? For our desktop application, so our desktop application has been around for years now. To be honest with you, automation has not been pushed here at Bluebeam until the last couple of years. So our aim is that testing pyramid. We are sort of maybe a rectangle, so to say. I'll put it that way. But we're making good progress, and that is our goal. That's when we look at our testing, how we want it to look like. I believe that once we hit that shape, then our releases will theoretically be pretty quick and with good quality. Because at the end of the day, we're doing all this for our customers. Do you want to?
Mm-hmm. Yeah, and I can answer a little bit from the cloud side. So it's one topic that's important to me. So I can say, at least from UI tests versus API tests, we do prioritize the API tests and have significantly more API tests than UI. For the unit test side of things, I myself have not gotten heavily involved with that yet, so I can't really speak to how many unit tests we have in ratio compared to the others.
So you mentioned return on investment. I think I saw a slide that calculates. So at Bluebeam, do you guys calculate the return on investment per every run, or what's your testing percentage in terms of how many test passes per execution? Do you guys have a full 100%, or what's the kind of return on investment, or how would you kind of calculate that if that was asked?
To answer your question, with desktop UI automation, no, not all of our tests are fully reliable 100% of the time. And if you ask me personally, I don't think, it's very difficult to reach that point with UI automation just because of the nature of UI automation. Going back to the testing pyramid, that's why you should generally have more unit tests and service level tests than UI, because they are more reliable than UI. In terms of our calculation for return on investment, just to give an example, we have automated close to 600 UI test cases for review. that would take a manual testing team generally a week to complete. We have multiple testing environments, so we're able to run those tests in parallel. It takes us less than 5 hours to run those tests. And let's say we get a build every day. Every time we run that batch of tests, we're saving a week's worth of testing. So that's one way, we can calculate that.
Yeah, so as I understand, you have a web, API plus mobile test in the same language, in the same repository, or it's like a separate project?
Yes, we have REST API tests, Selenium web application tests, and Appium mobile tests in the same language, in the same repository. And that was kind of one idea that I know not every company shares, not everyone does it that way, but it was something that I felt strongly about. I really like the idea of sharing that kind of consistency, and in particular when talking about the Selenium web application tests or mobile tests, oftentimes they can make use of APIs, the same methods that the API tests use. They can make use of those for the setup steps of those UI-based tests to make them a little bit faster and more reliable. So it's not necessarily the easiest thing to do. It might take some design, and it might make the repository look big, but overall it'll be less code than keeping them all separate, and it will encourage consistency across different team members. And it will also make it so that if one automation engineer switches from one area to a different area, they should be able to pick it up relatively easily, understand it relatively easily.
A follow-up question to that. Are your mobile applications native, or are they responsive apps, basically web apps?
The mobile applications, they're native applications. Yes.
Do you run, I'm sorry.
So for kind of like cloud services layer, are you maintaining like that environment to test against for your tests, or are you building that with each run, or using the live site?
So as far as environments go, for the web applications, right?
For the AWS cloud layer.
Yeah. So there are dev and QA and production environments, and we run our tests on all of them. Typically, the frequency that we run the tests on each of them is going to be correlated to how often the deployments of services are done to each of those. So with that, you're going to see the most automated test runs on the dev environment, and then a little bit less on QA environment, and then a lot less in production.
Other than scalability in the codeless variant of RAMRAX, what was the biggest challenge you guys ran into when implementing it? Finding anyone who knows.
Thank you. Finding training, pretty much on our end. We found that we spend a lot of time trying to train people to use RANRX in a certain way. And in general, we did have some success, but at the same time, we started thinking about providing them with, I guess, a path, like a career path, right? So we wanted to give, I guess, our engineers like a path to learning and to advancing. With the codeless approach, it works, but it stops kind of there. So that is part of the reason why you switch to a coded approach, because then you bring in that learning aspect, and someone wants to, maybe move into Selenium testing or advancing their career, there's more opportunities for them with a coded approach versus the codeless approach. I'm not saying that it doesn't work. I mean, it totally works. It's again, I think it's up to you, your organization, and your team to decide what's best for you. There's a lot of tools. RhinoX is just one of them, and they're not objectively like better than another. Like there's no clear winner, right? You have to decide like what is good for you and your team, and you have to do that with your team. You have to go through the proper evaluations and things like that.
Let's have a last question.
Scott, you mentioned that the reason for choosing C# was the code base is also written in that language. So my question is, are the developers contributing to the automation tests?
Okay, yeah, that's a good question, and the developers have contributed to our automated tests. It's not very frequent, but yeah, there have been a few instances where the developers have contributed, and that's gone well. And on the flip side, that I want to add is it allows us as automation engineers to easier understand the developer's code base, because sometimes not all of the developer documentation is there, so sometimes we need to look directly into developer source code in order to understand some functionality. And so by using the same programming language, that also helps us.
All right, thank you very much. Let's give them a clap.